New Zealand house indoor microclimate and allergen. New Zealand has a temperate climate with comfortable warm, dry summers and mild, wet winters. Housing design not only focuses on winter indoor thermal comfort, but also indoor health related to the high relative humidity during the winter. In New Zealand housing, the most common indoor allergens are from dust mites and molds. Research shows New Zealand has some of the highest levels of house dust mite allergens in the world. Visible mold growth on indoor surfaces is a common problem in over 30% of New Zealand houses. The abundance of two major causes of allergy, mites and mold, in New Zealand housing increase proportionally with average indoor relative humidity. The average indoor relative humidity in a house is closely related to the indoor thermal conditions, which is impacted by the R value of its building envelope and space heating. Based on the field study data of indoor microclimate, testing dust mite and mold, this study identifies thresholds or ranges of indoor microclimatic conditions related to different levels of dust mite allergen and mold growth. This study identifies the minimum requirement of indoor thermal conditions to control indoor dust mite allergens at an acceptable level and prevent indoor surface mold problem. This study also evaluates winter indoor microclimatic conditions of the two sample houses in Auckland with different R value in their envelopes. Research methods included field study of indoor microclimate, field study of testing dust mite allergen, and field study of testing indoor surface mold. Air temperatures and relative humidity adjacent to floors and ceiling of different indoor spaces in the sample houses and the shaded outdoor spaces under the eaves of the roofs were continuously measured and recorded at 5 or 15 minutes intervals 24 hours a day by temperature and relative humidity data loggers during the winter time. According to the instruction for the Ventia rapid allergen test, dust samples on the carpets of living rooms and bedrooms of the sample houses were collected by a vacuum cleaner fitted with a collector, and dust samples were then tested using the rapid test cassette. Test results can identify 4 different levels of dust mite allergens: undetectable, low, medium, and high. According to the instruction of Biotest Service, the researcher used clear standard sellotape to collect mold samples from the indoor surface areas of the sample houses. The sellotape with the mold samples was then folded in a non-stick baking paper and placed into a plastic bag. The samples were then sent to the local testing lab, where they were examined both microscopically and microscopically. Based on the field study data, this study identified minimum requirement of indoor thermal conditions to keep indoor allergens from dust mite and mold at an acceptable level. To control it at the acceptable level, indoor mean relative humidity adjacent to the floor must be maintained below 70%, and indoor relative humidity adjacent to the floor must be maintained below 75% for 20 hours a day during winter and below 80% at all time in winter. To achieve these conditions, the indoor mean temperature must be maintained at 70 degrees or higher. Under those indoor thermal conditions, indoor relative humidity never reaches the threshold for mold germination. If the mold spores never germinate in a house, mold will never grow on indoor surfaces. Those conditions can be used as the criteria to evaluate indoor climatic conditions of the local houses with different insulation and space heating under the local climate with a mild and wet winter. The criteria was used to evaluate winter indoor thermal conditions of the two Auckland sample houses with different R value in their envelopes. House 1 was built in 2000. The R value of building envelope was in accordance to New Zealand standards. House 1 had 2 occupants, used an electronic heater in the master bedroom only for the evening time during the field study. Table 1 shows winter indoor thermal conditions of House 1. Except the upstairs north master bedroom using temporary space heating, indoor mean relative humidity adjacent to the floor in the living room, the downstairs south bedroom, and the corridor were equated to or higher than 70%. Time per winter day in the living room, the downstairs south bedroom, and the corridor, when indoor mean relative humidity adjacent to the floor were below 75%, were less than 20 hours. Time per winter day in the living room, the downstairs south bedroom, and the corridor, when indoor mean relative humidity adjacent to the floor were below 80%, were less than 24 hours a day. The indoor mean temperature of the living room, the downstairs south bedroom, and the corridor were lower than 17 degrees. House 2 was built in 2012. The R value of building envelope was in accordance to New Zealand standard. House 2 had 2 occupants and did not use any space heating during the field study, although there is a heat pump. Table 2 shows winter indoor thermal conditions of House 2. Except the downstairs south bedroom, indoor mean relative humidity adjacent to the floor in the living room, the master bedroom, and the corridor were clearly lower than 70%. Time per winter day in the living room, the master bedroom, and the corridor, when indoor mean relative humidity adjacent to the floor were below 75%, were more than 20 hours. Indoor mean relative humidity adjacent to the floor of these rooms were lower than 80% for 24 hours a day. The indoor mean temperature of the living room, the master bedroom, and the corridor were also equated to or higher than 17%. According to field study data, to control indoor dust mite allergens at a low, acceptable level, indoor mean relative humidity adjacent to the floor must be maintained below 70%. Indoor relative humidity adjacent to the floor must be maintained below 75% for 20 hours a day during winter and below 80% all the time in winter. To achieve these conditions, the indoor mean temperature must be maintained at 70 degrees or higher. If indoor relative humidity adjacent to the floor can be controlled below the threshold for dust mites to thrive for 20 hours a day during the winter, it will not reach the threshold for mold germination. If the mold spores never germinate in a house, mold will never grow on indoor surfaces. If indoor dust mite allergens level can be controlled at low, acceptable level, the house is unlikely to have a mold problem in a temperature climate with mild and wet winters. For an Auckland house with sufficient insulation and double glazing window, in accordance to the current building code, except the south indoor space, the baselines of indoor temperature and relative humidity of indoor spaces without using space heating can meet the minimum requirements to control indoor dust mite allergens at an acceptable level and prevent mold problem under a temperate climate with mild and wet winters. A further study can focus on adding more insulation in the southern wall and limiting the ratio window area to indoor space volume of the southern indoor space for improving indoor thermal and health conditions of southern indoor spaces. For an Auckland house with base insulation and single glazing windows, the baselines of indoor temperature and relative humidity of indoor spaces without using space heating cannot meet the minimum requirement to control indoor dust mite allergens at an acceptable level and prevent mold problem. With temporary space heating, indoor temperature and relative humidity of indoor can meet the minimum requirement to control indoor dust mite allergens at an acceptable level and prevent mold problems. We want to acknowledge that this work was partially supported by the National Science Challenge funding and want to say thank you to certain individuals who gave us help and support to visit the sample houses. Thank you very much.